Hello and welcome to New Scientist Weekly. This is your curated selection of the week's science stories. I'm Rowan Hooper.
And I'm Claire Wilson. Welcome to the show. It's episode 200. Number. We're recording this on June the 14th. In the pod this week, we have Michael LePage, Alexandra Thompson, and Leah Crane. Hello, everyone.
Hello.
Hello. Coming up on the show, we're hearing about what Ritalin, the ADHD drug, does or doesn't do to help boost your concentration. In Life Form of the Week, we have an animal that can edit its own DNA, and we're going to ask why there's been such a lot of discussion among US lawmakers about UFOs and aliens.
We're also going to be hearing about a parasite that extends the lifespan of its host. But first, did you know that there are around 100 trillion bacteria in the human gut, Claire?
Of course I knew. Everybody knows that.
Yeah, I know. Okay, all right. Everyone knows that. There are lots of bacteria and other microbes in the gut, and they have a really important influence on our metabolism, on our nutrition, of course, on our immune function, and on things like mood. And it turns out this week on intelligence. Alexandra, you've been working on a story this week about this. Are we saying that gut bacteria can directly influence intelligence?
Actually, we are. I mean, I know what you're getting at. Previous studies have suggested that people with a higher level of education make different food choices to people with lower levels of education, which may then affect their microbiome.
Yeah, so the idea there is, if you've got a degree, then you know how to eat properly with fresh vegetables and stuff, and that gives you a healthy microbiome.
Yeah, so that would just be a correlation rather than causation. But in the study we've reported on this week, researchers have done an analysis that supports there being a cause and effect.
Okay, how can they prove that it's causative?
Okay, so this is complex. So in as simple terms as I can, the researchers, who are based in China, first analysed the microbiome and genome data of a group of 18,000 people. They then pinpointed genetic variants that are linked to people having higher levels of two types of bacteria in their guts. They're called Oxalobacter, and this is tricky, Fushicattanibacter. They then analysed the verbal and mathematical test scores and genome data of more than 250,000 people.
Wow. And so that was what they used as a kind of measure of intelligence, doing well on verbal and maths tests.
Yeah, and it's not a perfect proxy for intelligence. It's such a complex trait, and I think it goes beyond just doing well on some tests. But I think as a general gauge here, it works.
Okay, so what came next?
They found that people who are genetically predisposed to have more Oxalobacter species in their gut had lower test scores, and those with more Fushicattanibacter scored better. The researchers also carried out an analysis called Mendelian randomization, which uses the random genetic variation that occurs among people as a stand-in for randomizing people to have certain levels of bacteria in a randomized control trial.
Okay, so we want the bacteria that nobody can pronounce. And what were the results?
The researchers identified more than 150 genetic variants that have been linked to scoring well on these tests. And when they linked these to the two bacteria types, it suggests that these gut bacteria may directly affect our intelligence or these test scores.
So if people are genetically predisposed to certain bacteria, they seem to be smarter. Do we know how this is happening?
Well, with Fushicattanibacter, the researchers also linked it to a larger brain volume, which has previously been associated with intelligence. How Oxalobacter may lower test scores, however, is less clear.
So look, asking for a friend here, if a friend who was worried about his intelligence, should he go and buy some of this Fushicattanibacter supplements and boost his brain power?
Oh yeah, asking for a friend. So not quite. The research isn't there to support taking supplements to change our gut microbiome and then perhaps our intelligence. So if you and your friend are going head to head in Trivial Pursuit, he probably needs another technique.
Okay. But wow, this is another great example of the symbiotic bacteria and the influence they're having on us.
Now, it's Life Form of the Week, and we're moving from human intelligence to mollusk intelligence. Rowan.
Yes, cephalopod mollusks. This is about octopuses. As we all know, they have extraordinary intelligence. But here's another did you know? Did you know that they can edit their own genetic code?
Right, well, I did not know that. So
Thank
please
God.
tell us more. How are they doing that? Are they using CRISPR
CRISPR.
gene editing?
No, what they do, it's really amazing. They interfere with the instructions in their DNA. So I remember learning that DNA is the message and RNA is the messenger. RNA is what delivers the instructions of DNA to the parts of the cell where proteins are made. And what happens in octopuses is that they recode the messenger. So they change the RNA in thousands of places to alter the proteins that get made.
But the message is presumably very specific, right? I mean, it must have been in the DNA for a reason.
Yeah, of course. But I guess sometimes you want to change things on a faster timescale than, natural selection will allow. And that's what octopuses and other cephalopods are able to do.
So why are they doing it? What are they adapting to?
Okay, so in this case, it's colder water. So biologists tested this by changing the temperature of water in the octopus tanks to 13 degrees Celsius. And the octopuses made, more than 13,000 edits to the RNA. And that led to changes in the proteins. And the researcher, Joshua Rosenthal at the Marine Biological Laboratory in Woods Hole, Massachusetts, he says it's tempting to think they're doing this to acclimate to a changed environment. And this is where we show they can do that, at least to one environmental condition, which is temperature.
Is it just cephalopods that can do this?
It seems to be only them who can do it this well. Other animals do it on a tiny amount with enzymes that swap letters in RNA. But those edits normally take place in non-coding RNA. That's RNA that isn't translated into a protein. But cephalopods do it this really systematic way in coding parts, and we don't really know why.
And the changes to a lower temperature, are they adaptive in the sense that it improves their function or maybe the comfort of the animals if it's getting a bit too chilly for them?
Yeah. Well, there are hints of that. There are thousands of proteins involved in, resilience to temperature change and, whether you're hot or cold. But the researchers think that the time scale at which the changes occur suggests that the modifications are working for seasonal temperature differences rather than like sudden changes if you water currents brought an ice cube in or something.
And we started this section by talking about octopus intelligence. I mean, could this gene editing be behind their special intelligence?
Yeah, that's really interesting, isn't it? Some biologists do speculate that this results in a kind of special kind of evolution based on RNA editing rather than just DNA mutations and natural selection. So, they do wonder if it could be responsible for all this complex behavior and high intelligence we see in cephalopods.
Time for a break. And let us tell you about the science event of the year, New Scientist Live.
Mm-hmm.
So after the success of 2022, we are staging a hybrid event again, so you can join us in person in London or online from your own home.
It's a weekend of thought-provoking talks and amazing interactive experiences brought to you by the people shaping the world of science and technology. Find out more and book your super early bird ticket at newscientist.com/NSLpod. Now, we've got a story about lifespan extension, but not how we usually talk about it, and not in humans. Michael, this is about the weird effect that parasites can have, isn't it?
Yeah, so we know that parasites often have really dramatic effects on the animals they infect, but of course they're always almost harmful to those animals. So for instance, cordyceps fungi make ants climb up branches and anchor themselves in a high place so that their fungal spores can spread further when the animals die. But in the case of one tapeworm, its effects are to make ants live at least 3 times longer. So normally worker ants in this species only live around a year, but the infected ones live at least 3 years long and possibly far longer.
Wow.
What's more, they don't have to do any work, so they just stay in the nest instead of going out foraging, and the uninfected workers actually care for them and feed them and look after them.
Right, so at the level of the individual ant, it's actually quite good to be infected, perhaps.
Yeah, I mean, it's probably a better life for those ants. It really could be. I mean, of course, we don't know if having the tapeworm inside them causes them any suffering, but I suspect if they were sort of being stressed and sort of suffering, they wouldn't live as long as
Mm,
they do.
mm.
Of course, as you're saying, for the ant colony as a whole, this is going to be bad news because you've got all these ants that are sort of lazing around
Yeah,
doing nothing.
yeah. Okay, so what's in it for the parasite? Why is it manipulating these ants somehow to live longer?
So the main host of this tapeworm is sort of woodpeckers.
Mm.
So they get infected when they find the ant nests and they feed on the infected workers. So by making the infected workers live longer, the parasite increases the time available for woodpeckers to find nests and to feed on those workers.
Wow. I saw a woodpecker the other day. It was behaving really strangely, and when it flew away, I went over to see what it was doing, and there was a dead mouse on the floor, and it'd been licking ants off the mouse.
Ooh,
So, because obviously, yeah, like you say, they feed on ants a lot, and,
yes.
have these really long tongues. So perhaps, perhaps that was getting infected there. So the woodpeckers get infected by eating the ants, but how does the ant get infected?
Well, apparently this species of ant likes to collect woodpecker feces and take them back to their nest to feed to their larvae.
Mm.
So, yes. So if there are tapeworm eggs in the feces, they infect the larvae.
So if the ants get infected from woodpecker feces and the woodpeckers get infected from eating the ants, who started this whole thing?
Well, that's the classic chicken and egg question,
Yeah.
isn't it? Yeah, we'll never know.
So when you
Yeah.
say the infected ants might live longer than 3 years, we don't actually know, do we not?
No, no one actually knows how much their lives are extended. There are
Mm.
anecdotal reports of 7 years or more.
Wow.
So the researchers were telling me the problem is that this kind of study tends to get done by PhD students who don't hang around for that long to sort of find out the full lifespan.
Yeah, well, I mean, ant queens can live for many years, can't they? So it's not,
Yeah.
it's not beyond the bounds of possibility. Do we know how it might work then? That how the life extension might work?
Well, that's what this team at the Gutenberg University in Germany has been trying to find out. So they've been looking at the blood or the hemolymph of the ants, and they found that the parasites secrete around 260 proteins that can be found in the blood of the ants. Now, two of the most common ones are antioxidants, so it's possible that the antioxidants are extending the lifespan. But most of
Yeah.
these proteins are actually completely new to science, so we don't have a clue what they do yet.
How amazing. And I just love that there's all these levels of connectedness in
Yeah.
ecosystems once you start looking more deeply. I mean, what other parasites have similar effects? Do we know?
Well, we only know of a couple, and their life extending effects are much smaller. So, for instance, there's another tapeworm that extends the lifespan of the beetle it infects, but it's only about a third, so it's not nearly as dramatic.
Now let's return to the subject of intelligence. This time, we want to look at what happens when people take what are sometimes called smart drugs to give themselves an edge or to meet a deadline. Claire, you've been writing about this, and I have to wonder if you helped get to your deadline by a bit of smart drug taking.
No, that is not something that I would do. And it's not something any doctor would recommend. So just to recap, here we're talking about people using stimulants that are normally prescribed for people with ADHD or attention deficit hyperactivity disorder when they don't have the condition. These medicines they're thought to be able to help people with ADHD by raising their dopamine signaling in their brain. And they seem to help people concentrate in class and focus on their schoolwork and so on. So some people without ADHD figure, well, I need to concentrate a lot this evening when I'm revising for this exam or get an essay done that I've left too late. So people either buy the drugs online or maybe from friends who have been prescribed them, don't need all their pills.
And we should say that this can be illegal depending on where you live in the world. But look, what have the new results found?
Well, they're quite surprising, actually, because in a proper randomized blinded trial, the same kind of trial that would be done to test any medicine, the people not knowing if they were taking the drugs or a placebo, people actually performed slightly worse after taking the drugs.
Oh, no, you perform worse after taking smart drugs.
Yes,
That's not what I
so
paid for.
not yes. So in one sense, it's not that surprising. The medicines were designed to help people who are thought to have a deficit in their dopamine signaling pathways. So if you don't have that deficit, who knows what the effect might be? As an analogy, if you're a bit tired and you have some coffee, that can help you feel more alert. But if you have too much coffee, say if you have 2 double espressos and you're not used to it, that can make you feel kind of wired, a bit too buzzed to be able to
Yeah.
properly focus. Yeah, I don't know if you've ever had that
Yeah.
experience after too much coffee.
Yeah, yeah, yeah.
Um,
So
yeah,
why then? Why do we hear so much about these smart drugs? They apparently really popular, and we've heard surveys about
yes.
up to a third of US college students are taking these things.
The researcher that I spoke to had a really interesting insight about that. The drugs affected people's performance in quite a nuanced way. So, first, I need to explain what the task was, and it's called the knapsack test. It's done on a computer, and you have to choose from multiple items in terms of different weights and values to fill your knapsack, making the total contents as valuable as possible without breaching a weight limit. So, there's two
Mm.
different kind of variables to consider. And you can repeatedly try different combinations, like you might in real life if you were trying something out.
Okay, so if you have the smart drugs, how did it affect the outcome?
Yeah, well, people actually did a bit worse in one measure of their performance in the value of the bag's contents. And the drugs took them longer to get there. They tried more different combinations before they gave in their solution. So the researcher who's at the University of Cambridge said to me that you can translate that to somebody trying to solve a problem in real life. So if you imagine after the stimulant, they might try more options and they might feel very productive and busy, but it's not
Mm.
actually helping them get a better solution. So a
Wow.
bit like, yeah, if you had too much coffee, you might be just too wired to be very productive and useful.
Wow, that's really interesting. So, maybe just do it, do it and move on. I will, I'm going to bear that in mind next time I'm caning too much coffee. Now, that's the Sci-Fi Alert, where we talk about something in the news that's already been in science fiction. And last week, NASA held the first public meeting of a panel established to investigate sightings of UFOs. And then, a former US intelligence official named David Grusch claimed that the US government had intact and partially intact alien spacecraft. As you might expect, there was a lot of media coverage about this. Leia, please pour some cold water all over it, and me.
A thing to mention first is that they're not actually calling it the UFO group. They're calling them UAPs, which just stands for Unidentified Anomalous Phenomena. That's anything in the sky that can't immediately be traced back to an aircraft or a known natural phenomenon. And NASA's created this group to look into the data that we have on aliens and really sort of figure out what's going on.
Yeah, I mean, because it's not like they've got other things that are more important to do, right?
Personally, I'd lean towards, yeah, they do have more important things to do. But the idea is to really dig into the data that we have about these UAPs and understand what they are, which is in every case, they've got data good enough to dig into. It's not aliens. There have been more than 800 reports of UAPs, and almost all of them are traceable back to mundane sources.
Right. Okay. So that's unsurprising. So let's go to the claim of this intelligence official.
Sure thing. That one has been getting an awful lot of press.
Yeah. So this guy, David Grusch, he is not your normal conspiracy theorist by any means. He's a decorated combat officer in the United States Air Force. From 2019 to 2021, he was a representative of the National Reconnaissance Office, which reported to this UAP, the Unidentified Aerial Phenomena Task Force. And he was co lead for that analysis. And he's given an interview now alleging that the US government has retrieved non human exotic origin vehicles that have either landed or crashed, as well as the actual aliens who piloted those vehicles, which is like some claim to make.
Yeah, the thing about that claim, um, there's always a thing, is that he didn't give any physical evidence. What he said was that he'd heard from others in the intelligence community that they found alien ships and even the dead alien pilot. So what it is a third-hand report with no proof. So I'm not giving it a ton of mind.
So it's amazing there's so much belief in this stuff, isn't it? Especially among right wing politicians, it's really taken off. They seem to think that the Pentagon has got they literally think there's a whole load of secret funds being devoted to research into alien technology.
I feel like it would be hard to pull one over that big on the public. Scientists are not good at keeping secrets, but I'm sure someone's trying to research aliens, and keeping an open mind about this stuff is good. Plus, it's not like, as far as we know, This is anything more than a tiny footnote in NASA's budget. But the idea
Right.
that aliens have actually visited us has always been more the realm of sci-fi than anything else. Personally, I doubt we'll find currently existing intelligent aliens. The likelihood that they would exist close enough to us both in time and in space seems so minuscule as to be unimaginable to me. If we're going to find any
Yeah.
alien life, my money's on microbes.
Okay, but having said all that, we should say that we have an interesting story on how a supernova that was discovered last month is being used by astronomers as a possible way of detecting alien communication, and we'll put a link to that in the show notes. But Rowan, what actually was the sci-fi link there? Oh, hang on. Need I ask?
Yeah, it was the X-Files, the show from the 90s about a fictional department in the FBI involved in alien cover-ups.
Oh, is it really fictional?
Yes, thank you, Agent Scully.
Yes.
The truth is out there.
That's all for this week. But before we go, I wanted to pay tribute to the great American novelist Cormac McCarthy, who's died this week, aged 89. Now, I'd read quite a few of his books, but I didn't know until now that he was a life trustee of the Santa Fe Institute in New Mexico. He had an office there, and he was a friend of the great physicist and Nobel Prize winner Murray Gell-Mann. And his last novels, The Passenger and Stella Maris, are apparently really influenced by the ideas of mathematics and physics that he explored at the Santa Fe Institute. So I'm off to read those now.
Thanks to our guests, Michael LePage, Alexandra Thompson, and Leah Crone. And thanks to you for listening. I'm Claire Wilson.
And I'm Rowan Hooper. Thanks, and we'll see you next week. Bye for now.
Bye.
Bye.
This podcast is produced by OG Podcasts. Find out more at ogpodcasts.co.uk.